Hello and welcome. Thank you for joining us. It's Isaac speaking from Solibri. I'm joined by my colleague Simon Gilbert, our technical services manager. And today we're going to be discussing and overviewing achieving quality across the construction industry. So without further ado, a little bit of a background on Solibri for you. So we're the market leader in BIM quality assurance and quality control. And our customer base spans across the construction industry from major contractors, construction companies, architects, engineering firms, and Solibri has a global footprint. Our head office is based in Helsinki in Finland, and we are a part of the Nemetschek group. So we're the UK arm of Solibri. So first and foremost, it's worth just taking things back to their roots and discussing what actually is quality. And if we define it generically, the quality of any product or service is achieved when it conforms to the desired specifications. But relating that to this industry, quality in construction is conforming to the brief, those project deliverables, making sure that the production of our data and information is reliable and therefore then fit for purpose. And when we review our processes, a bit of a thought-provoking statement here is the way that we've always measured quality good enough for our future? And complacency is a bit of a buzzword at the moment, just alongside things like interoperability. But considering the path that it took to get to where we are, is that always enough to get to where we're going? Bit of an analogy for a personal statement here, but I was brought up in a family whereby if you say sorry for something that you did, you shouldn't make that same mistake again. You shouldn't have to say sorry for the same thing. And I had siblings that would remind me of this lesson quite a lot. But if I didn't have them around and I didn't have that family, nagging me and telling me of these lessons, would I have changed? And to use that analogy, that life lesson, it's a small, relatable example of commercial requirements. And if we share those morals and new ways of thinking with each other, the stronger we will become. So quality assuring projects. Is clash detection a part of this? A question that comes up quite a lot. And yes, it is a small part of it, and it's probably the best way to put it. When we're referring to quality assurance, we are talking about a set of planned, systematic actions to help us be compliant against the requirements of the project. Clash detection is just one of those requirements. So what else can we actually do to quality assure projects? So going beyond the basics, understanding the project quality plan, reviewing those requirements of the project is going to be key in order for us to prevent errors and delays. And to give an example, or a few examples, you could say, we're talking about compliance with building codes. I'm not going to get into every single example here, but as part of our demonstration today, we'll show you a little bit more about going a little bit further, going beyond clash detection. So considering your backup plans, ways to review performance, your policies, your priorities, the earlier you do them, the more financially cost effective it will be to standardize what you see on screen in that list. Unfortunately, issues do end up on site and issues do cost us a lot of money. And we reduce the risk of them happening when we have the right tools in place to support quality assurance. And the aforementioned checks that were on the previous slide will help us, and we can accomplish those within software, Solibri software. So when we focus on connectivity of software, it's also key for communication effectiveness, being able to collaborate with others. Using file formats like BCF BIM collaboration format enable us to communicate effectively what we're actually looking at. And naturally, working to fix the latest issues on the latest models. So getting into BIM properly, it means having the right tools and the right processes in place. And naturally, risk, reputation, and money is on the line if we don't. So from a reactive mentality to being proactive with quality assuring projects, this is a bit of just a general quote to share with you, but the more disastrous the mishaps, the simpler the reviewing task. But to counter that and to challenge that, can we always afford to learn from our mistakes? Glaring errors aren't the only issues worth overcoming. And is it too late if the mistake's already happened? So we challenge ourselves about our quality assurance processes and then challenge Solibri to let us know and we'll tell you if we can help you. And then when we prepare for the different stages for deliverables, i.e. such as Kobe, and calculate how much time is used to repeat the same issues across multiple projects. When we actually recap on our previous experiences, just consider the way that we can be better moving forwards. And change is always on the horizon. It's a part of what makes our journey. This industry is ever evolving, and always consider that change is on its way. So in the world of BIM, we are creating more data than ever before. If the data is not correct, we are potentially creating more problems than we're solving, and BIM cannot deliver on its promise. I read that word for word because it's a powerful statement and there's no point in moving away from it. It really is that simple. So without further ado, I'll move over to Simon, who's going to showcase and demonstrate just how this works within Solibri Office.
Okay, thank you, Isaac. And there we go. So we should now all be seeing the Solibri model checker on the screen. What we're looking at now is the building information model. We have two models loaded here. One is the architectural model and another one is a mechanical model. So the architectural model is that set of components, and the M&E are those set of components. So it's a simple basic model to show the functionality of the Solibri sort of engine. Has data related to the components, and then when we move to our checking area, we have a list of checks that we can actually carry out. To check the model, we click on the check button at the top here, and it then executes the rules that we have that we've defined within this project. So we've already discussed Isaac's already mentioned about clash detection. Clash detection within Solibri gives us the ability to do things like duplicate checks to ensure you don't have the same kind of components sitting over the top of each other, as well as components that sit inside other elements. But generally, we also have the ability to then start looking at, say, in this case here, building services and other construction components. So a typical clash, when I click on the overview level at the top of these issues, we see all of the data related to what's in this section. So you can see here, this is all the items related to the cemented ceilings, whereas these are all the items related to the walls. Now, this gives us like an overview against the issues that we're looking at, and we can then drill down into the individual cases if we want to. So we can go down to this one of those clashes here, and then when we get down to the level of the triangle here, which is the actual issue itself, it then lists the components that are the problematic items. So here's our wall, and we have a couple of duct fittings that then are going through that wall component. Now, we also have what's called related components. So Solibri actually has relationships. Those are defined within the authoring system, but come through via IFC to add a much richer sort of view on the model itself. And we'll see how that affects the ability for us to use that within rules as well later on using fire ratings. So here, what we can do is see the context of the system of where that duct actually clashed with that wall. So we're not just looking at the information as far as an individual clash in the building where it exists, but we can actually start using these relationships to embellish or to improve the understanding of what's actually happening within the model. We also discussed about project deliverables, and most of those start off with either clash detection here from providing a coordinated building, also the ability to then check data. So one of the first things that people need to be able to go and check is that the actual model files themselves conform to ISO 19650. So we have a rule that we've actually created here using one of our rule templates, and the rule basically goes through and checks to see whether our models, which are these two here, which are the naming of the models here, conform to that standard here. So what we've got here is the national annex for the UK, and this is 2.2, and here we're checking the masking value. And the masking value says basically that this MEP-based model doesn't conform to the syntax that we've got set up within this rule. So the rule has obviously passed one of these models, and the other one has actually failed. And then from then we can then pass the past model into the subsequent checks to make sure that although it's passed the individual syntax so the masking values, that each of the individual values that make up that are also correct. So here we might look at something like the available roles, and if we look at the parameters for this, you can see you can then put the allowed values in here. We can load those up from a spreadsheet and update those relative to the actual project if you need to add two figure values here, 2 character values for project requirements. So that's sort of data at a very basic level, which should be checked on every project. If we go down to our, so a good example of checking other data would be for Kobe, for instance. In this model, we have Kobe data here, and we've just taken a couple of the fields that we might check for Kobe deliverables. One of them might be that it should have an asset type. And so what we have is a rule here that says go away and check that actually the values are either fixed or movable for items that are of this parameter. And what we're doing is we're checking all the Kobe assets in the project, and we're then filtering them by the type. So we haven't got them based upon the individual components. So what we've got now down here is all of the elements that basically don't have the asset type set to either fixed or movable. So they're incorrect values at this relevant stage. Now, for any rule inside Solibri, we obviously get the failures, we also get the passed elements. So we can actually see that the model has checked 208 elements. You can see it's passed these 56 here. And if we just select them, you can see these are the components that do actually have fixed or movable elements against them. So we can interrogate each of the rules to see what's going on. So although it actually shows the failed elements, we can see the passed ones as well. Now, this is relatively simple because we're checking a field value which is passed or failed. If I go to something like Uniclass, where we're checking for a classification system applied to components, if we look at this one here, what we're doing here is we check the same set of assets here, but actually we'll check this classification. So this is a classification here, and what we're saying is it must be defined, and then we'll sort the issues related to type. So you can see it's already failed, and what we have is 3 sets of components which are all sorted out by their types that don't have a Uniclass classification. That's controlled by our classification functionality in here, and you'll see that if we scroll up, we actually have one called the Kobe Uniclass here. And if we look at the list that have been classified, so these are all our items that have then passed because they're defined, and these are our undefined sets of elements. Now, the list here is a singular list, and it will list each component of those types. But what we really want to do is not to create a slide for each of those issues to fix those problems, because realistically we've only got 3 issues, as we've already seen. The classification works on the premise of that it's checking the set of components, so it's not checking the whole model, and it goes down these values here and evaluates whether or not actually it has this as a PR value. When it finds this within the locality that we specify at the top here, which can be changed, it then gives it the actual classification name, so we know that it's going to be correct, and we know it's going to be conforming to the pick list value. So in this case here, if we go back to our checking area, we've got our 3 sets of issues here. And if we wanted to create slides of those, then we can then say add a description, specify who needs to fix that. And we can do the same for each of these in the same way. And obviously with using Solibri Office, if you have, obviously we're running this in Solibri Office, so you now have to actually have auto run, so you could create these dynamically. And again, we could then also generate the presentation dynamically from here as well. So we'll just create the presentation. It creates the 3 slides here, and automatically then we can either synchronize them with an issue management system or report the data out to a BCF report. Or generate a traditional styled detailed report just in Excel, which would list that data. So that's the process, and these are linked back to the issue results. So when we get a file that comes through that then updates the model, we should actually see these being rectified by the relevant consultant, who's then should have added the PR values for these components as far as the classification. So that's really checking data, and data is relatively easy to check within Solibri. But as we said, it goes a lot further than that. And the first things are to do with, we've looked at clash detection, but obviously then there's requirements for certain items to touch other items. So here we have an example of a rule that checks that elements that we have in the model must touch other elements. So we have a situation here where we have columns, and the columns we're saying must actually have some kind of bearing object on top of them. And what this is actually showing us in this model is that these columns that we see on the screen have nothing between them and the roof slab above it. So that's 450 millimeters. Now, this is also a really good tool that if you set the element to be 100% for the element here and the opposing element that it should actually be touching, you can use it as an alignment tool, which is really very useful. And you don't really have to worry about the distance between them, because you can set a allowable amount of either overlap or gap between those elements. So it can also be used as an alignment tool throughout a project, checking things like columns within a project don't get larger than the ones at the bottom, that type of thing. So this is like checking things are touching them, and then we can then move on to things that are checking areas in front of components and behind components. So we have another rule here where we define basically a box, and the box is defined upon the element we're checking. So it takes the width and the length of the box and the depth of it, and we can then modify that relative to the original component. So you can see in this case here, we're checking a volume in front of and behind elements. Now this is incredibly useful for things like doors, where you might have clashes with the door swings, you might have service elements, you might have bracing across the backs of doors, you might have beams that cut across the doors, things like that, which we see on a regular basis within projects. So it's a very, very useful rule to actually check that that we're actually getting the data correct in the model. Now, a good example of this is this suspended ceiling example, where you can see that the suspended ceiling is not actually physically a clash with the window units you see here. It projects the amount onto the floor plan of the to give us a 2D representation of the amount of area that's taken up by those elements. But if this ceiling was actually set back a certain distance, then obviously we wouldn't see a clash in here. It's not a physical problem, but obviously it's an aesthetical based issue here. Would be if the windows opened inwards, for instance. So useful, and also we can use this functionality to apply to almost any element. And in this case here, I've just given you an example with the elements we've got in the model, where I've just put a large value in here just to show that it's actually checking the area in front of, say, a wash hand basin here. Might be an electrical cabinet, it might be all those kind of components that you actually want to check that there is that free area in front of those components. So we may have also the ability to check spaces. We can check them for their validation to make sure that the boundaries are correct. In this case here, the boundary doesn't match the physical sort of walls that are around there. That would give us a problem related to volumes, and also would obviously give data incorrectly for things like schedule of accommodation. And again, we could then run a rule for schedule of accommodation. We can pull in an Excel spreadsheet of the targeted values and the space names we're expecting to be in the project, what tolerances are actually required on those, as in what percentage tolerance, or minimum and maximum sizes for those rooms. And what it does, it gives us a list of the failures in the model. So for instance, here we have a restroom, and it says there are no spaces which are this size here, or give or play 10%, which is the name of the restroom. That's because down the bottom here we have this other section area here which says extra spaces. So down here we have men and women. So obviously in this project where the definition should have been restroom, they've been made wrong mechanism. So again, we can check that we have the right spaces defined as part of the brief with the schedule accommodation, just using the rules that are within the box and then manipulating them. Very much like that with checking some kind of conformance, things like corridor widths. For instance, if we're doing sort of part M kind of basic checks, you can see here that what it does is it traces the half the thickness that we put in as a requirement for the corridor widths and puts a boundary around here. So where you see the boundary, that's half the width we put into the actual rule. The areas of green are the accessible areas. And what it's actually indicating here is the doors that we see on the floor plan here, which are red, are inaccessible because the corridor is too narrow. So it gives us the ability to analyze the actual model. Solibri gives us the ability to visualize the results, not just saying where something's passed or failed, which is really key. Now we've looked at things like distances between elements, as in items that we actually need like clear space between elements. In this case here, we might actually require. Let's look at that requirement. So the distance between elements. So what we've got here is clear areas above ceilings. So this rule here, if I right-click and look at the rule parameters, what we've got is a rule that checks the minimum requirement. So this is saying we need a minimum of 400 mil from the item on the left-hand side, which will be our ceilings, to the actual floor slabs above. We're saying that it's going from the top of the ceiling to the bottom of the floor slab, and we need 400 mil. What this is actually showing us is we've got these failures here. So we've got our floor slab, as you can see, and if we then rotate underneath the model, we can then see our ceiling. And there's 7 instances of this, and you can see that the minimum gap here is 260. So you might want to combine this rule and say, actually, we've got a minimum requirement here, but then also we could then change the actual parameters to say that obviously when it gets above 800 mil, then above these ceilings, we might have to check for fire detection devices within that ceiling void area. So we can actually start then stacking these rules, as we'll see in a minute. Again, checking distances, door leading edge checks. So in this rule here, what we've got is a floor plan view, which is then checking basically the area of the door leading edge value here that we can see. The rule gives us again the ability to check other data in this rule. So in this case here, we're checking this parameter, and you see as we highlight it, it highlights the parameters in the box where we can actually start changing the values that we want to check inside the model. So in this case here, it's highlighting to us that the wall is obviously encroaching within that 300 mil distance between there and the line. So it's kind of, it's giving you the indication, and you obviously for each of these where we get the problems, we can then also create those slides to advise the consultants or the people in-house within your own teams to fix these issues. You might want to then check distance between elements on the model to say that we must have a component within a certain distance of another component. So here we actually have a situation where it's checking WCs and against wash hand basins. What we're saying here is a WC must have a wash hand basin within 750 millimeters of it. Now the actual floor plan takes that shape, projects it down for the object that we're looking at, and then measures from that projection over a 2.5D dimension, so the 2D dimension here in this case, using the 3D geometry, and it's telling us it's 936 here, and we've actually required it to be 750. So if I look at this rule, you can see that we're using 750 here, and we're using a different mechanism with this rule that says horizontal distance between the footprints, and we project them down and measure the distance between the two. So that's what that's done. But in this case here, what it's doing is it's actually checking a complete sort of radial sort of tracking on that. And if there was a wash hand basin within the women's toilet here, then basically it would say it's passed if it's within this red area. So that's obviously not acceptable. So what we can do with these is we can add context related to the spaces within the model. So hence checking the spaces are modeled correctly in the first place. What we can do is then restrict this just to the space itself. So if I recheck this model and then look at the actual data now, you'll see that what we have here is it's now only checking that space. So it ignores the rest of the model and just checks the distance in this physical space itself. Now that can be extended. So if you're checking things like we've got models which are accommodation for, like flats or those types of things, or apartments. What we can do is we can start grouping elements. So we have a special classification inside Solibri called our space grouping classification. And you'll see here what we have is one that's set up called Other. And if we look at the education and conference areas in here, you can see that what it does, it takes into account these different areas. Within Solibri, we have the functionality called space grouping. What that does is it gives us the ability to see this data. We can see, if we look at that education and conferencing here, we can see it's 99 meters squared. And the spaces that make up that area, you can see are being shown on the screen now. So you can see there is individual spaces, but it also does the calculation of those grouped areas across the plan. So it's useful for exporting data and getting this kind of these area or combined areas. But we can use this within the same rule. So if we go back to the rule again now and we use that classification, so we'll go into here and say use a space group now, and then specify the space group that we're going to use. So we can drop that down and say we used other here. Again, just at the bottom here, we can say that actually we only require one wash hand basin for the target elements. If we then run the check on the model, you'll see now what it's done is extended that area related to that space grouping. So now it's found 2 wash hand basins, but both of those are too far away from the WC that we see on the screen. So very, very useful using that sort of context with any kind of components, really. So I'll take you through 2 other things that Solibri is able to do, and what we'll look at first of all is sort of relationships. So if we go to the relationships here, I'm just going to go back to an information takeoff again here. And what I've done is I've set a classification. Now the classifications inside Solibri give us the ability to look at the model using the data against the elements. So in this case here, what I've done is I've created one called fire ratings for doors and the walls within the project. And I've color coded those fire ratings to 0 minutes, 30 and 60, because that's what we have in our model. But already what we can start to see, and we can also list this out within an information takeoff as well, but you can see straight away where we get these mismatches. In this case here, we have a door that has no fire rating, and we have a wall that has a 30-minute fire rating. So visually, we can see this data really, really easily, but it helps to add context to the actual rule results as well. So when we go to our checking area here, and we're now looking at our relationships and looking at the rule results, what we're now seeing is the data then is incorrect. So what we have here is a door that doesn't have the right rating. It doesn't have any rating. We have this one here that has the wrong rating. It has a 30-minute rating instead of a 60-minute rating. And these rules are checking the parameters of this object against this object using a relationship. So if I right click on the rule here to show you how it's configured, what we're doing here is we are checking the doors, and what we're doing is checking a parameter called fire rating. We then check in the same wall that basically that we check the wall itself, and then we check the wall's fire rating, and we're saying that it's got to be greater than or equal to, less than or equal to, in this case here, to create a correct result for us. Now, if we select the wall itself, we're using these relationships here. So the relationship has a void in it, and if I double click on the opening here, this takes us to a situation where we have the filling element, which is the door, and back to the wall here. So if we go to the door here, we're now looking at the door information. So we're using the data that's inside this door, but using this relationship functionality to go and check that data against those elements. So finally, really, we've seen a number of different templates within Solibri driving different results. What I'd like to do is just move over to finally using what's called gatekeeper rules. And gatekeeper rules means that we can use any of these types of rules and use them with each other to refine the information that we're actually seeing. So within this rule here, the first rule that we might be looking at, so this will just show the actual model here. So we look at the M&E model, for instance, here. What I might be doing within an M&E sort of check, as I might want to check that if I had, for instance, electrical conduit that I hadn't got any ductwork or pipework within a certain distance of those elements running in parallel within a certain distance. So I can go away and check that kind of information. So the first thing I might want to do is isolate all the horizontal and vertical sets of elements. So straight away, if I go to the first rule here that we've got, the first rule I've created is the identification of the horizontal ducts. So if I right click on this rule, all I'm doing here is using that same comparison rule again. I'm saying go and select a duct, go and set the target value for that duct to be the start offset, and then don't factor it anyway. Use the actual components, the check components, and then set the constraint end offset value and say they must be equal to each other. So what that does in the background, if I look at the data, is it's checked these 150 elements here, which are the ones we see on the screen. And we see the ones that have passed are these elements, so they're all our horizontal ones. And the ones that are failed, if you see the results here, are all the vertical and the non-horizontal elements here, these angled ones. So very, very simple to actually highlight all those horizontal elements. So what we do is we then pass the past elements to the next rule. And the next rule, what we're doing with this rule is we're saying, well, I'm not interested in the small segments. What I'm actually interested in is physical runs of pipe work. So I want to look at anything that's over a meter in size. So what I can do now is if I look at it's now gone down to 92 elements, which was off the previous one. I can now look at the past elements. So these are our longer sections of those same pipes. And if we look at the failed elements, these are all the smaller segments, as you can see. So we've basically isolated by using a set of parameters the items both from a horizontal down to a size check, which means now we're going to get something meaningful when we go to the final rule here, which is using our distance that you've already seen. So we're now using our distance between elements, but we're using horizontally alongside now. And by using the horizontally alongside with a certain value, we can then go away and check that of the 19 elements here, we've got two failures, and we've got these ones that have passed. So if you look at the two failures, we're automatically seeing that our 200 mil is being breached at this end of the well, basically anywhere across here, which is 66.8 millimeters. So you can see that we can use either the relationships in the model. We can also use the different rule templates that we have within the model, and we have around about 60 of those rule templates. And we also have an API which enables you to generate your own rule templates for checking your own custom sort of solutions within Solibri. And then you can obviously stack those rule templates, like I've done here with what's called a gatekeeper rule, to pass the passed or failed elements, whichever we're interested in, to the next rule to check other conditions, or to subsequently check the next condition or within that model. So hopefully that gives you a bit of an insight to the kind of checks that you could actually start to move forward with, and try and address some of these issues to do with the project, not only from a basic coordination point of view and a conformance as far as the data in the project, but also any of the requirements that are needed, or the kind of things that crop up and cause problems time and time again. So thank you very much. I'll hand you back to Isaac now just for a summary.
Fantastic. Thanks very much, Simon. So hopefully you can all see my screen just for the last slide. But again, hopefully that was an insight into achieving quality with Solibri. And again, just to summarize, we're looking at the early identification of issues, improved modeling and the modeling standards. We're providing a sustainable quality assurance platform and toolkit for you to utilize against your projects. And naturally, we're looking to de-risk and reduce costs across your projects. So back to yourself, Sita. Again, thanks very much for listening and taking the time to be with us today. And that's everything from us.